7-3 rational exponents. We're going to take this in two chunks. So here's part one. Basically, what we're going to recognize is this cool little rule right here that says b, or anything to the 1/2 power, is the same thing as the square root of whatever it is you're taking to the 1/2 power. Here's why that works. Remember, if you have something squared, that's the same thing as saying that it's being multiplied by itself, right? And when we have exponents, what I need to do is add those exponents. So a half plus a half is b to the 1st power, which is just b. So what you're telling me is b to the 1/2 squared is just b. Well, check out what happens if you do the same thing with the square root of b. If I square that, that allows the radical sign and the squared to cancel, and I just get b. That's how we can say that b to the 1/2 and the square root of b are the same. Okay? So, first we're just going to rewrite them. If I have the a to the 1/2 power, that's just the same thing as the square root of a. If I have the square root of 22, that's the same thing as 22 to the 1/2 power. Where you have to get careful about things is where the parentheses are. So notice that the 1/2 is acting on the entire 7w. That means it's going to be the square root of 7w. Okay, if this had been 7w to the 1/2 without the parentheses, then the w is the only thing being taken to the 1/2 power, so it would just be 7 root w. Okay, so now check out 1d. X is the only thing that's to being square rooted here, so it would be the x to the 1/2. Let's pretend for a minute that it was the square root of 2x. Since both of them need to be taken to the 1/2 power, that's where I would use parentheses. Here's the cool thing about square roots. What we don't realize is that actually it looks like this, the square root. But because square roots are the most common root that we do, we don't write the 2 all the time. So if you see a radical sign and it doesn't have a little number here, assume that it's a 2. Now what happens if it's not a 2? They're going to write it. But then that means that it changes the fraction. So, for example, they have here, they don't write that very well. Okay, we'll just do an example ourselves then. This is going to be, this third is going to come over to be the exponent. If the square root of 64 is the same thing as 64 to the 1/2 power, then the cube root of 64 is going to be 64 to the 1/3 power. Notice the 2 matches this 2, the 3 matches this 3. Okay? And of course you can rewrite it the other way. So this just comes to the outside. Now you have the cube root of 27. And then if you notice so far, everything has had a numerator of 1. That numerator came from the exponent that is with the 27. And since there's not one written, we assume that it is 1. Well, what happens if it's not 1? You get an example like 4a. And basically all you do is take this 3, and that's what gets to come to the outside, and your 27 is going to stay squared. And it doesn't matter if you write that squared underneath the radical sign, or if you pull it kind of to the outside like that. Either way, it doesn't matter. It's going to work out to be the same. You can do it the other way as well, which I don't have any examples of pulled up, so we'll just write our own. Let's say I have the 5th root of 32 to the 4th. So the way that you would rewrite this is by taking the 5 and it goes underneath. So it would be 32 to the 4/5 power. All right, that's where we're going to pause today.